The whole point of the similarity topic is that it's supposed to enable you to do questions lightning fast. So, for example, I could try and trick you into thinking that this is a SOHCAHTOA question. I give you that that's 8 and that that's 6. Maybe you think that I'll make that a right angle. So you can use SOHCAHTOA to find this, and then you can move that over there using vertically opposite angles, and then maybe I tell you that this is 4, and you can now do, because you know this angle, you can now do SOHCAHTOA to find that. But you don't need to. These are similar triangles. The angles are the same. Because of the parallel lines, that must match that. Because that matches that, we can be sure that all the angles match. Well, I kind of knew that anyway because of the right angles. And so therefore, this is in the topic where if you double one thing, you double the other. When I see an 8 becoming a 4, that's halving. Therefore, the 6 becoming the x also has to be halving. So x therefore equals 3. That is supposed to be done lightning fast. But there is this trap. And the trap is that you must notice when the clue, so this is the clue, and the question are about different items from this list. And the list is very short. It's length, area, and volume. If you get a clue about length and a question about area, that's the trap. If you get a clue about volume but a question about length, that's the trap. If you get any mismatch, so a clue about one of these but a question about any of the others, then it's a massive trap and you must adjust for it. Now, here's an example. So let's say I give you that this is a two similar shapes, and I tell you that this length is 3, and I tell you that this length is 9. I tell you that this area is 10, and I ask you, what would this area be? Now you're correct to spot tripling there, but please do not triple the 10. Instead, kick in this procedure. What you do is, you take a deep breath, and you lay down at least 3 arrows. The reason why I say at least 3 is because sometimes you actually need 6. Okay? But anyway, for a straightforward example where it's obvious how the 3 becomes a 9, you just need 3. And what you do is you write in your details. So 3 became a 9 in a length. And you write that it's timesing by 3. And then you complete details on all 3 of the other arrows. And these should always be such that that squared is this and that cubed is that. There's no direct connection between this and this. The connections are this. That squared is this, that square rooted is this. That cubed is this cube rooted is that. And now you fill in the details. We'll be given an area question. So therefore x equals 90. Okay? I'll give you another example. Let's say I give you a volume, and this volume is 8 litres, and this volume is 27. And I ask you, if this area was 4, what would this little area be, assuming the two situations are similar? Well, you write your 3 arrows. And you write your clue. So we had a clue about volume. So an 8 became a 27. Now it's not at all obvious to me how an 8 becomes a 27. So this is a classic situation where we actually write 6 arrows. An 8 becomes a 27 via the number 1. First you divide by 8, then you times by 27. Now, you now complete the conversion factors, the scale factors on the other 3 arrows. Remember what I said before, there's no direct connection between those two. So don't do that one next, do this one first. That needs to be the cube of that, so that's got to be divided by 2. That needs to be the cube of that, so that's got to be a times by 3. That needs to be the square of that, so that's divided by 4. And that needs to be a square of that, so that's times by 9. So now that all our arrows are complete, we can now do the question. We have an area of 4. You divide 4 by 4, you get 1. You times by 9, you get 9. So that's the answer. So it's 9, whatever it is, square centimeters or whatever. I'll give you an example with a calculator now. So let's say we had an area of 5 becoming an area of 7. I tell you that these shapes are similar. I want to know what would happen to this length of 3. Okay, so here are your 3 arrows. For area, we have a 5 becoming a 7. It's not at all easy to see how 5 becomes a 7, so let's go by the number 1. First we divide by 5, then we times by 7. Now, got to complete the arrows. That needs to be the square of that. That needs to be the square of that. And that needs to be the cube of that. And now we can answer the question. So we had a length of 3. So 3 divided by root 5 is 3 over root 5. 3 over root 5. Oh, I don't know why I wrote a divide by there. It's clearly timesing. Sorry about that. You pump that through a calculator and you'll be done. One last example. I give you a volume. 5 litres becomes 2 litres. And I want to know what, if they're similar, I want to know what happens to this length of 3 centimeters. How long would that be over here? So we've got a clue about volume, bit of question. Trap. So in the volume of 5 became a 2 via the number 1. So this needs to be the cube root of 5. This needs to be the cube root of 2. Even though you're not asked about area, it's always important just to get in the groove, convince yourself that you know what you're doing. That needs to be the square of that, and it is. This needs to be the square of that, and it is. Note that there's a crucial difference between this and this. That is a cube root being squared. That little number indicates the type of rooting. If there's no number there, it's square rooting, and that is a plain odd powering of 3. So we've got our scale factors sorted. I can now answer the question. I had a length of 3. 3 divided by cube root of 5 is this. And now we get the answer, which is 3 divided by the cube root of 5 times the cube root of 2. And that's it. That's our answer.